Hello students, welcome back. So now I'm going to show you how you can detect outliers using KNN. KNN is short for K nearest neighbor. So first thing I'm doing is importing my numpys and pandas. I'm also importing matplotlib and seaborn. I'm also importing this nearest neighbor, this particular method right here. This is responsible for finding your nearest neighbor. Then I'm also importing standard scaler. This would be for scaling your data, for standardization of your data. So in this case, I'm using this data breastcancer.csv file. In case if you do not have this file, you can actually get this directly from here. So I wrote down the steps over here. All you have to do is just uncomment these lines out, and this way you can actually get it directly from your sklearn data set. So you can import that directly from there too. Okay, so first thing I'm doing, I'm reading my breast cancer CSV. I'm printing 10 samples. So over here, let's scroll down. So these are like some of the values you can see for first 10 sample values. And so this one has 31 columns. And okay, so let's look at the shape. I want to see how many rows and columns I have. So in this case, I print my df.shape. And this one has 569 records and 31 columns. So now let's separate our features and targets. So in this case, I'm taking my X value. I'm taking every data frame, every value in the data frame except the target. I'm dropping the target column. And I'm keeping my Y as a target. By the way, this value, I would not be using it. This is just redundant. Okay, so going forward, I'll be working with this X right here. So first thing I'm doing is feature scaling. Anytime when you use this distance-based algorithm, like for example, your KNN, you have to make sure that no one column dominates the other. So in order to do that, you want to scale your data. In this case, I'm going to call standard scaler, and I'm going to fit that. I'm going to supply that X to that, and after that, I'm going to transform that. So now my data is X scaled. So my X has changed to X scale. So going forward, I'll be working with X scale right here. Okay, let's print out the first two value of my X scale. So this, you can see that this is my first data point right here, and this is my second data point. And you can see that your values have been scaled now. So this value now, if you look at all these values, these are all pretty much scaled now, all standardized. So now we're going to apply our KNN for outlier detection. So the idea is this, that for each data point, for every data point, you compute the distance to its kth nearest neighbor. K can be any number, it could be 2, 3, 4, 5, could be any number. So the points that are very large distance, there are points that are very located at a far distance, these are your potential outliers. That's the idea. So let's look at this thing. So in this case, I'm putting my k equal to 5. In other words, I'm going to look at 5 nearest neighbors, and I'm calling this method nearest neighbor, and I'm supplying this 5 over here. And then I'm fitting that. I'm giving the X scale data to this KNN. And then after that, I'm trying to get my neighbors. I'm trying to get the distance. So this method right here, k neighbors, is going to return two values. It's going to return distances and indices. For our purposes, distances is the most important one. This distance actually is it's the distance to the k nearest neighbor. That's what this distance is for each one of the points. Okay, and then I print out the length of my distances. So in this case, the answer comes out to be 569. And the reason it is 569 because there are 569 total data points. So it's going to calculate the 5 nearest neighbor for each one of the points. So that's why you're getting 569 total records. Let's print out our distance. So we know what the distance looks like. So this is my distance right here. When I print the distances, you can see that this is my distance for the first one, second one, third one. So let me explain this thing in detail. This one right here, this represents the 5 nearest neighbor of the first data point. This one right here represents the 5 nearest point of the second data point. This one right here represents the 5 nearest data point of the third data point. Sorry, 5 nearest neighbor of the third data point. That's what these are. So likewise, you can go all the way at the end over here. Okay, so each one of these values, okay, so this one right here, let's go with this first one. So if you notice, all the first ones are 0. You see, this is 0, this is 0. Well, that's because the nearest neighbor of a point is the point itself. So that's why the first value is 0. Now the second value, this is your second nearest neighbor. So in this case, the second nearest neighbor, the distance is this. For the third nearest neighbor, this is the distance. The fourth nearest neighbor, that is the distance. And the fifth nearest neighbor, that is the distance. So this stats right here is for the first data point. Let's look at this one right here. For this one, the excuse me. So for this one right here, this is the first nearest neighbor is the point itself. That's why 0. The second nearest point, the neighbor, has the distance 2.87. The third nearest neighbor, it has the distance 2.53, and the fourth nearest neighbor is 2.71, and the fifth nearest neighbor is 2.75. So this stand right here is the five nearest neighbor for the second data point, and likewise for the rest of them. So in this case, I'm just wrote in a little note for over here for you. So the each column in this case is a distance to the first nearest neighbor, the second, the third, and likewise, and so on and so forth. So okay, coming back down now right here. So I want to calculate. Okay, so now I want to know the distance to the fifth nearest neighbor. So that would be my this point, right? This one right here, the last one. Okay, this one. So this represents the fifth nearest neighbor. So I just want that number. So in this case, I'm just using distance. I'm saying grabbing all the rows and grab me the last one, the last column, and then I print out my k distance. So when I print out my k distance, this gives you the k distance for the fifth nearest neighbor for the first data point, the fifth nearest neighbor for the second data point, the fifth nearest neighbor for the third data point, the fifth nearest neighbor for the fourth data point, and likewise for the rest of them. So you can see that all these numbers right here, these are these numbers right here. You see that 6.07, 2.75, 2.93. All these numbers are basically this one, this one, this one. Okay, let's come down. So these are all my 569 data, 569 total distances for each one of the data points. And coming down right here, and now we add our distance to the data frame. So I'm creating a new column called KNN underscore distance, and I'm putting k distance over there. Then I'm printing my df sample again. So just to show you that particular column. So if you come down, you will see that column somewhere. There it is, KNN distance. So this particular point in the distance, the fifth nearest neighbor is has a distance 2.67. The fifth nearest neighbor for this data point is 3.57, and the fifth nearest neighbor for this data point is 2.85. And now we choose our threshold for outliers. So in this instance, I'm choosing the 95th percentile as my threshold. So I'm trying to find the point that would be a 95th percentile. So in this case, this is the formula I'm causing np dot percentile. This is the method I'm using. And in this case, it returns my threshold. And so my threshold is 5.37. So what this 5.37 means, that 95% of your data, okay, it is below 5.37. All right, so that means any value that is higher than this, I would consider that as an outlier. Okay, so I'm creating a new column called is outlier, and this is going to be true or false depending on whether this condition is true or not. So in this case, I'm just checking this distance. Any record that has KNN distance greater than a threshold, that would be greater than 5.37, that will be true, otherwise it's going to be false. So I print out this df now, and now you're going to see that column is there you go, is outlier, this one right here, and you can see that it says false, false, false. That's because the distance right here, each one of the distance is smaller than 5.3 right there. Okay, and so let's count our outliers. I want to know how many outliers are here, by the way. So in this case, I'm just doing df is outliers dot sum. That's going to add all the true values in this column, all the true values that's present over here. It's going to add them all together, and the answer is 29. So there are total 29 outliers in this data. So the total data is 569 records. All right, so let's inspect our outliers. I want to see my outliers. So in this case, I'm just filtering my outliers. I'm just saying show me all the outliers where is outlier equal to true, and then I'm printing the few values, and you can see that these values are my outliers. So you can actually come down and you can see that KNN distance, you can see that it's basically 6.07, 8.47, this thing. So this one is the fifth, the distance of the fifth nearest neighbor is 6.07. The distance to the fifth nearest neighbor is 8.47. The distance to the fifth nearest neighbor is 6.81. So these are all your outliers. So that's what's happening over here. So after you have found your outliers, now you can handle them the way you see appropriate. So let's, in this particular instance, what I'm doing, I'm just doing some more visualization just to draw these points. In this case, I'm plotting that, and I'm plotting the k distance this time. And so let me just decrease the size of the screen so you can see what's happening. So this is my KNN distance plot for outlier detection. This, by the way, is optional, not mandatory. So what I'm doing over here, I'm just seeing how many data points are there, and this is the how many the distance, the KNN distance, which is a five. That will be, yeah, that will be five nearest neighbor distance. So let's look at this one. This is 100. So this is telling me there are 100 data points where the fifth nearest neighbors, the distance is 2, approximately 2. There are 200 data points whose fifth nearest neighbor is like 2.1 or 2.2, 2.4 or 2.5, something like that. Let's look at this one. This is 400. So this tells me that there are 400 data points whose nearest neighbor is, I would say, 2.7 or 2.8 or maybe 3, something like 3 or something. All right, so this is how you read this thing. So this is your number of data points, and this one is the five nearest neighbor for that number of data points. And this right here is the threshold right here. This is the threshold that I'm applying. So that's what this distance is, y equal to threshold, the one I just showed you. And then all these points right here, okay, all these points, these are your outlier points. So how many are there? Well, you can see there are approximately 29. So you can count, I think there were 569 total. So this would be somewhere like 29. Yeah, so these seems like 29 in count.